I'm the Amateur Logician from amateurlogician.com. Here's a pop quiz, Are You Logical? Based on the distinction between validity versus invalidity. Question 1 of 2, is the argument valid or invalid? Premise 1, all A's are B's. Premise 2, C is a B. Conclusion, thus C is an A. Is it valid or invalid? Does that conclusion necessarily follow from those two given premises? Think about it. Answer. Premise 1, all A's are B's. Premise 2, C is a B. Conclusion, thus C is an A. In fact, this argument is invalid. And here is one way to think about invalidity. Let's say we start with all true premises, and then through an argument nevertheless reach a false conclusion. This implies that the argument must in fact be invalid. So we can show invalidity by counterexample. For example, consider this. Premise 1, all dogs have 4 legs. That's a true premise. Premise 2, my cat has 4 legs. That's also a true premise. Conclusion, thus my cat is a dog. That's a false conclusion. Now notice that this follows the general structure of all A's are B's, C is a B, thus C is an A. But uncontroversially, we have true premises but a false conclusion. So that structure, that argument must in fact be invalid. Question 2 of 2, is the argument valid or invalid? Premise 1, no A's are B's. Premise 2, some C's are not B's. Conclusion, thus some C's are not A's. Is it valid or invalid? Does the conclusion necessarily follow from those two premises? Answer. Premise 1, no A's are B's. Premise 2, some C's are not B's. Conclusion, thus some C's are not A's. In fact, this too is invalid. And once again, we can show invalidity by counterexample. Consider premise 1, no rectangles are circles. That's true. Premise 2, at least some squares are not circles. That's also true. Conclusion, thus some squares are not rectangles. That's false. In fact, all squares are technically rectangles. Moreover, this argument follows the general structure of no A's are B's, some C's are not B's, thus some C's are not A's. Here we have uncontroversially true premises, but a false conclusion. Therefore, the argument must in fact be invalid. You can visit my website at amateurlogician.com for more content like this, including an extensive tutorial on beginning traditional verbal style logic. Until next time, bye for now.